amazing world of the Pythagorean Theorem and its converse today. Not its shoes, the Converse, but like its actual Converse. Anyone wear Converse? Just saying, some Chuck Taylor style. All right. Learning goals, Pythagorean Theorem and its converse. What's the different parts of a right triangle? So think back to what we've talked about right triangles. I've referenced it a bit this year, but a little more so. If I have a right angle, I know I have a right triangle then. What are these things, these rays, or excuse me, these segments coming off that right angle called? Cameron? They are called legs, okay? So if you're looking and you want to reference the actual names for these things, those are called legs. What's this long one across from your right angle? Yes. Yes, hypotenuse, okay. Hypotenuse. Hypotenuse. All right. Just so that we're clear. This long side is called the hypotenuse. And we have the legs. Now, generally, when we're dealing with the Pythagorean theorem, what we call the legs are A and B. And just because I do this, I usually call the shorter one A and the longer leg B. Now, you don't have to do that. You could reverse them. Just as long as you call the legs A and B. All right? The hypotenuse is always our C. So if we're labeling these sides, side A, side B, side C. Okay? Maybe we put the C right here. But you see? I see. Okay. All right. Now, we didn't hit the Pythagorean theorem last year in algebra, at least if you had, most of the algebra classes didn't. Maybe your class did, but this summer, if you were here, we hit it. You should have had it back in 8th grade. What is the Pythagorean theorem? Ooh, a couple of us. Yeah, Maggie, what do you got? It is a squared plus b squared equals c squared. So that's saying a squared plus b squared equals c squared. That means if I square this side and I square this side, the sum of those two sides squared will equal that side squared. And generally you could, I better give myself a little more room if I'm going to draw that. But if I'm showing that, there are a lot of different ways you can show this. But really, if we call this length A and I draw a square off that side, a square off that side would have the same length, A, and it would go just like so. So this would be A by A, or we call that A squared, the area of that. All right? I want you to do that same thing for the other two sides in your notes right now. Draw a square off each side. All right, so we square off of each of these sides. That would be our b squared. Okay, b by b gives us b squared. And let's square off this side. Okay, right angle, that's c by c, or c squared. So what this is saying if I take the area of this square and add it to the area of this square, I will have this total area. Okay, now it's a quick sketch of it. Now you can actually prove that mathematically by actually physically making these squares and cutting them up and piecing them together so that this square would fit, these two squares would fit into that square. How many of you have seen this diagram before? Now the reality is you won't necessarily have to use this. You'll use a theorem. You'll use this today. Understanding how this works and for those of you who actually copied it down, you're preparing yourself to actually study mathematics. How many plan on going to college? Okay, you better know how to study mathematics, because what happens is you end up getting a textbook and you learn a lot from that book or from online resources because you don't spend tons of time in class learning. Okay, so it's important to do this. That's why I had you copy it down. If you chose not to, remember, I don't check your notes, but if you choose not to do that, you're not preparing yourself. And the unfortunate thing for that is that when you get to a point like in college and it gets really hard, dude, that's a tough time to learn how to prepare yourself. How many have friends that are in college? Siblings? Ask them how quick their classes move compared to their high school level classes. What we cover in a year, sometimes you're covering in a semester or a quarter in college. So think of accelerating your course. You better know how to take notes, know how to read your textbook, know how to study math. Okay, you'll see this a lot in a book. Okay, who came up with the Pythagorean theorem? Tell your neighbor who you think it is. Anyone know? Cameron? Yeah, the guy's name's Pythagoras. He actually had this crew of people, and they would get together and they'd meet in their little club, and they'd talk about math, kind of like some of you do. Okay, you get together with your friends, talk about math. All right, and Pythagoras was the spokesperson, so they would go out and they'd talk about math, and then he'd come out and proclaim all this stuff that they came up with, and so he got the Pythagorean theorem. So I guess it could have been someone else that came up with it, but he is credited for the Pythagorean theorem. That's why we call it Pythagorean theorem. You go to Greek city, they like have little areas that mark Pythagoras, like he's some kind of rock star over there, but not really. I mean, he's no longer with us, unfortunately. It was a long time ago. Oh, I know. All right. So Pythagoras came up with the Pythagorean theorem. I want you guys to check out example 1 in your textbook. So you need a textbook. Make sure you're ready to discuss any questions you have about it. Okay, example 1. This is called indirect measurement. Okay, indirect measurement is when you can't actually, when it would be difficult to physically measure something by hand. So you can indirectly measure. You're measuring a length here and a length here, and if you have a right angle, then you can measure the hypotenuse of that length. Okay, that's indirect measurement. And right now that's just Pythagorean theorem. You're like, well, maybe I wouldn't use that, but we use indirect measurement a lot when we can't measure stuff. Okay, when you get to advanced algebra, you'll deal more with sine, cosine, and tangent if you haven't already done that in some of your engineering classes. Some of you may have been dealing with that. And you'll deal with law of sines, law of cosines. Okay, that kind of stuff, that's another indirect measurement. One of the projects we do with Trig at the end of the year, if we can go through it, is we figure out some distances around campus. We set up transits and measure that way. Okay, so how many of you are in advanced algebra? Or, excuse me, geometry as an 8th grader right now. Okay, you'll be in advanced algebra here, Trig, next year, so you might be in that class that does that. Kind of depends upon our new textbook too, but it's a fun project we like to do, doing some indirect measurement. So, any questions on that one? All right, I want you guys to go ahead and take in, we'll get into Pythagorean triples here in a minute. I want you to take a look at number 7 in your textbook, or excuse me, on your worksheet. And I want you to try your best to find the value of each variable. Work with your partner. Try number 7. Think you got it. You can try 8 and 9 as well. Hey, so we've got our a squared, our b squared, and our c squared. I just like to label these. If that's a, that's b, that's c. Okay. In that case, it says leave your answer in radical form, by the way, which we'll talk about here in a minute. But if a is q, okay, and I'm using my formula, a squared plus b squared equals c squared. A is q, so I'm going to plug that in for a and square it. B is 2, I'm going to plug that in for 2, or b and square it. And c is 3, I'm going to plug that in for c and square it. So I get q squared plus 4 equals 9. Now I better at least see that on your paper right there. Okay, those of you that are calculators, you don't write anything down. You just plug it into your calculator, and then if you miss it, you're like, I don't know why I missed it. And I go, neither do I. Dude, I can't tell. Okay, so I want to see at least that. Better loop your q. Okay, q squared plus 4 equals 9. I subtract 4, so I get q squared equals what? 5. And then I take the root. Q is? Dude, root 5. That is simplest radical form. There's not a perfect square that goes in 5, so we leave it like that. Okay, and our label would be units because we don't have, they're not giving us a label up there. So root 5 units. Root 5 is about what? Not on your calculator. What's the perfect square right before 5? 4, which root 4 is? 2. And the perfect square after root 4 is? Or after 4 is? 9. Root 9 is? 3. So it's in between 2 and 3. Which one's it closer to? 2. Because root 5 is closer to root 4. So if you think of it this way, root 4, that's 2. Root 9, that's 3. Root 5 is closer here, so it's closer to 2 than it is to 3. Okay, quick way to estimate your answer. 2 point something. Did anyone actually do it on the calculator? What is it?
It's like 2.236.
Okay. Okay, we'll leave it in radical. Any questions on that? Okay. Go ahead and try 8 and 9 if you haven't done so already. Give you a minute or two there. 8 and 9. Okay, a squared plus b squared equals c squared. What is our a this time? Our a is x. Either that could be a or this could be a. What's this one if that one's a? This one's b. 12 is c. Now those of you struggling finding c, just trace the right angle. The side you don't trace is c. Okay, so if you trace that at right angle, the side you don't trace is your c. It's always the side opposite your right angle. Okay? All right. So, in this case, I have x for a, I have x for b, and I have 12 for c. This is x squared plus x squared is? Okay, so 12 squared is 144. What's x squared plus x squared? Is it x to the 4th or is it 2x squared?
2x squared.
Good. This is 2x squared. You have 2 of these. Okay, you're not multiplying, you're adding, so you have 2 of those x squared. So what's my next step there? Cameron? Divide by 2. So x squared is equal to? 72. Half of 144. Now what do we do?
Square root.
Take the root. So x squared, or x is equal to the root of 72. Simplest form? Is that simplest form? Who says yes? Who says no? Who says I don't know? Okay, guys, we need. If I don't have participation, then I have no idea if we had. So who says yes? Who says no? Who says I have no idea? Okay? Someone that said no, which is the correct answer, why? Good, Grace? Good. The perfect squares can go into it. You guys studied this last year in algebra. Okay? What perfect square goes into 72? Yeah, is he? 9. Okay? Now, if you think of for those of you like, I don't even know what a perfect square is. That's your 1 times 1, which is 1, and that goes into everything. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 25, 36. Those are all perfect squares. You want to know what perfect square can go into that. Now, in this case, 9 does, but what else does? 4 does. What else does? 36 does as well. So which one should you use? Well, that's up to you. I mean, if you want to use the smallest, that's fine. It just means you're going to have to reduce more. Kind of like a fraction. Okay? If you can use the biggest, if you can figure out the biggest perfect square, then you don't reduce quite as much. So for instance, if we go with the 9 that was suggested first, this becomes root 9 times root 9 times what is 72? 8. Root 9 times root 8. That's what 72 breaks into. And root 9 is 3 times root 8. Now I'm going to have to skip down here because I worked into that. So if I have 3 root 8, now you have to ask yourself, is this root simplified? Is there a perfect square that goes into 8? Yeah, which one? 4. We never count 1. 1 goes into everything. Okay? This is 4. So root 4 by root 2. And then the 3 just comes down. It's like your tag along. It's your brother or sister that wants to hang out with you, your little sibling. They just want to tag along. They're like, dude, I'll be quiet. I'll just like cruise around. They're like cruising around with you. Okay? 3, this is 2. So 3 times 2 times root 2. 3 times 2 is 6 times root 2. Perfect square that goes into root 2? 1, and we don't care about 1, right? I mean, we care. We just, 1's the loneliest number, man. Just saying. There's a song about it even. Okay? All right. There we go. 6 root 2. That's our answer. How many of you remember simplifying radicals last year? Dude, we harp on it in my class, man. Okay? Like we do it tons. How many remember from the summer? Kinda? Okay. It's totally radical. All right. Any questions there? I know. All right, let's try number 9er. Niner. You got root 106. Anyone else get root 106? Dude, okay. So we got our A, we got our B, we got our C. 25 plus 81 equals C squared. 106 equals C squared. And C equals root 106. Well done. Can that be simplified? No? 4 doesn't go into it? Okay, the way I test that, I just cut it in half. Cut it in half once is 53. Cut it in half again. You can't cut it in half again. If you can cut it in half twice, 4 goes into it. Okay? So it doesn't work. How about 9? Anyone know the rule for 9? Add up the digits. 1 plus 0 plus 6 is? 7. Does 9 go into 7? Nope, so 9 doesn't go into that. Okay? Any number 9 will go into, you just add up the digits, and 9 would have to go into whatever that sum is. Here are your divisibility rules right behind me, so those are good things to memorize. Root 106, there we go, and we could test a few others, but it wouldn't work. Very good. And that's units. Okay? Questions? Okay, all you secret agents out there that can't bring out your earbuds without being reminded, neighbors, make sure you remind them so I don't have to ban them from class. Okay. A triangle has lengths of 7, 8, 9. Classify the triangle as acute, obtuse, or right. Well, let's talk real quick. We know this statement. We know if C squared equals A squared plus B squared, then our triangle is? It's a right triangle. I mean, it's the converse of the Pythagorean theorem. If C squared equals A squared plus B squared, then it's a right triangle. Versus if it's a right triangle, then C squared equals A squared plus B squared. Okay? So if it's equal, you have that. Well, let's say I take a Pythagorean triple. Anyone know what a Pythagorean triple is? Okay, Pythagorean triple is like 3, 4, 5. 3, if I take a triangle with a side length of 3, you got to tell me if this stays on the screen. Are we good? Everyone see my side length 3? 1, 2, 3. Okay. Okay, 3 pin caps. I hope I have enough. And then I take a side length of 4. 2, 3, and 4. Okay, everyone with me? Okay, and then I take and put a side length of 5. 2, 3, 4, and 5. Dude, that is a Pythagorean triple. Okay, it's a Pythagorean triple because it makes a right triangle. 3, 4, 5 is a Pythagorean triple. Here's my right angle. Everyone with me? Okay. 3, 4, 5. So if I'm writing down Pythagorean triples, I would write somewhere, hey, if I have 3 and 4, I automatically know this is 5. There's no math involved. Or I could double it. If I had 6 and, what would this be? 8, then this would be 10. Or if I had tripling it, 3 times 3 is 9, and 4 times 3 is 12. 5 times 3 is 15. All those are Pythagorean triples. Okay, there are other Pythagorean triples you're going to see today, and that just means you get perfect whole numbers for each side. Anytime you see a Pythagorean triple, it's something you should make a note of. That way you just automatically know them. Okay, so here's the question. We know if a squared plus b squared equals c squared, then it's a right triangle. What happens if I take off one of those? Now a squared plus b squared is? It's not equal to. Is it greater than or less than? Or think of c squared. Is c squared, now that we made it smaller, is c squared going to be greater than a squared plus b squared or less than? Okay, well, let's go back. 3 squared is 9. 4 squared is
16.
Okay, 9 and 16 is 25. What's c squared? 25. Okay, so this plus this is how much? 25. I took off a piece. What is this length now? This is now 4 squared, which is 16. Is this length now greater than or less than these two? Less than. What type of triangle will that form? It will form an acute triangle. If I move this side like that, in order to make this a triangle, what was my right angle down here has now become an acute angle. Okay? Yeah, it's pretty cute. Okay? It's less than 90 degrees. So what we need to think to ourselves, we know that a squared plus b squared, if it's equal to c squared, it's a right triangle. However, if c squared is less than a squared plus b squared, what type of triangle is it? What type of triangle do we have? Yeah? Yeah, it's an acute triangle. I can if I set it here. Just can't see the triangle. Okay, so what statement am I missing there? Cameron? Greater than. C squared is greater than a squared plus b squared. All right, we'll go back here. Let's go back and make my 3, 4, 5. Okay, there's my 3, 4, 5, my original triangle, my right triangle. And now if I add a side length. Okay, if I go ahead and add a side length here, and let's add it up here so I have room. I now have 3, 4, and 6. In order to make this work, I have to swing this side out. And what was our right angle has now become an obtuse angle. This is now obtuse. Okay? So if we have c squared is greater than a squared plus b squared, we get an obtuse triangle. Okay? So what are we basing all of our stuff off of? What side? We're comparing c. If c is equal, if c squared is equal, it's right. If it's less than, it's acute. If it's greater than, it's obtuse. So if I want to know the answer to this question right here, a triangle has the lengths of 7, 8, and 9. Classify it as acute, obtuse, or right. Okay? Talk to your neighbor. What is it and why? Who says acute? Who says obtuse? Who says right? Okay, not everyone voted, but let's go. A squared plus b squared equals c squared. Let's check it out. We'll put a question mark there. A and B are our two shortest. C always has to be the longest. So C would always have to be the longest. So 9 squared, 7 squared, and 8 squared. 7 squared is 49, 8 squared is 64, 9 squared is 81. What's this make? 100 what? 113. Okay, is C squared equal to A squared plus B squared? No. C squared is what?
Less than.
Yeah. Okay, C squared is less than, or that 113 is greater than 81. So if I'm here, I'm putting that symbol right there. If C squared is smaller, that means it's a cube triangle. C squared is smaller. It's a cube. Okay. All right. Any questions there? All right. There you go. You add those to your notes right now. Simplify those side or those radicals. Okay, for those of you struggling with this, it'll be good for you to write down your perfect squares at the top of your paper, excluding 1. 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on. At least out to 100 there. Okay, and then when you're simplifying 27, perfect square that goes into 27 is what? 9. So we get root 9 times
3.
root 3, which is, root 9 is 3.
Square root 3.
Square root 3. 3 root 3. Okay. All right. So James, give me a perfect square that goes into 20. 4. Root 4 times, what is he?
5.
Root 5. Okay. So Logan, what's this simplified to? 2 root 5. All right. Root 4 is 2. 2 root 5. Nothing can go into root 5, so we're done. Root 72, Emily. What perfect square goes into 72? 36. Root 36 by root what, Megan? Yeah. 2. Okay. So what's this simplify to, Jackson?
4 root 2.
Almost. Something root 2.
Oh, sorry, I was doing 6 root 2.
6 root 2. Okay, good. Rory, number 4, perfect square that goes into 32.
16.
16. Root 16 by what, Carson? 2. Okay, Maddie, what does that simplify to?
4 root 2.
4 root 2. All right. Kira, perfect square that goes into 48.
Oh wow, I skipped that one.
That's all right.
Let's
Start with 4. Does 4 go into it?
yeah.
Yep. So root 4 by
12.
root 12. So that gives us
2.
2 root 12. Maggie, can I simplify that anymore? Yeah? What goes into 12? 4 and 3. So root 4 by root 3. Don't forget to bring that 2 down. Some people just circle it saying that's the end of that line, but I'm going to have to use it at the end. Okay? Root 4, root 3 becomes 2 root 3. So at the end, if you circle all your ends, you can just say, well, I got to multiply the whole number, so that gives me 4 times root 3. Now at the beginning, some of you maybe used, instead of 4, you use 16. So you could have done 16 root 3, which would have, root 16 root 3, which brought you to 4 root 3. Okay, questions on that top row? Diamond, number 16. Yes, root 25, root 3. Okay. Make sure we bring that 14 down. Blake, what's that simplify to?
5.
Okay, that becomes 5 times root 3 times 14, which becomes what, Hannah? 70 root 3. Okay. You're good. Multiply those up. Julian, perfect square that goes into 125. 25. Well done. 25 times? Times 5. Okay, bring down that 10. Chase, how's that simplify?
Simplifies to 5 times 10 radical 5.
Okay. And that ends up being what, Bethany?
I got 50 radical 5 is my answer.
50 root 5. Yep. Good. All right. Questions there? What's that? Yeah, if I'm not quite done. Jocelyn, what do you get for 160? Perfect square that goes into it. May not have made it there yet, but maybe you did. How about 16? I'll help out?
Yeah, but you put 16 in there, you get 10.
Root-
Root 10 and root 16.
Okay, yeah, so 16 times 10, a little tougher, okay? Times 3. Okay, we're done with that piece. 16 becomes 4, and the root 10 just drops down, so we're left with 3 times 4 times root 10, or 12 root 10s. Okay. I expect that you guys know how to simplify radicals. Okay, so if you're struggling with that at all, you need to talk to me as we go through, okay? All right. Okay, everyone take a look at your assignment. Now, I expect to see work. However, one way that I allow students to show work on Pythagorean Theorem is I allow you, let's say you're doing number 10. I allow you to look at this and go, hey, 10 squared is what? 100. So I allow you to write that right there and put 100 and circle it. 12 squared is 144. Now, please understand why I'm allowing that, because those of you that participated today in the warm-up, remember, 10 squared is like having a square right here. So I'm showing the area as 100. And 144 squared is like having a square off of this side. Okay? So that is 144. That means this over here is what? Well, it's a squared, right? Okay, so you're adding these two to get that one. Okay? So I allow you to go like this, and then you need to know, hey, in this case, am I doing this plus this and taking the root? You need to be able to say a squared plus b squared equals 144. Okay, and then solve from there. Any questions?